Hi, my name is Hetal Patel. I'm a rising sophomore at the University of Southern California, and I'm currently studying environmental studies. And I'm also a volunteer at Future Frogmen. I've been for a couple years now, and Future Frogmen is an organization that's focused on multidisciplinary education of our water planet. And today I'm pleased to have this conversation with Patricia Maria Stathatou, a postdoctoral researcher at MIT in Cambridge, Massachusetts. Patricia is from Greece and has several advanced degrees from the National Technical University of Athens. Thank you for joining us, Patricia. Would you like to tell us about yourself a little bit?
First of all, thank you, Hetal and Richard, for having me here today. It's a great honor for me to be part of the Future Frogmen webinar series. So I'm really excited to be here. I'm from Greece, as you said. I'm a civil engineer, and my PhD is in chemical engineering. And for more than 7 years, actually almost 8 years, I was a researcher in Greece in the National Technical University of Athens. And I was participating in projects that had to do with water. They were funded by the European Commission. I came in the US this January, actually less than 6 months. And I'm now a postdoctoral researcher at MIT. I won a scholarship from a very big and famous philanthropic institution in Greece, which is named the Patricia Foundation. It's a privately owned but for public benefit organization. I won the scholarship and I came here to do my postdoctoral research.
I noticed that you've worked with European consortia on water-related projects and issues, and you've also published some publications. I was wondering how these opportunities came about and if you could describe some of these.
When I was finishing my diploma, in Greece we are calling the engineering degree a diploma. We're not have the bachelor's and the master's separately. So it's 5 years diploma. So when I was finishing in civil engineering, my thesis then was also related to water and the water footprint concept. I presented it in a conference, in an international scientific conference in Greece. And I met there my future boss and professor who owns a lab in the chemical engineer department at the National Technical University of Athens. And he runs different projects which has to do with water and are funded by the European Commission. So European Commissions allocate some funds and actually supports proposals which had to do with several environmental, and not only environmental, but also environmental aspects, and water is one big aspect of them. These proposals are submitted by European consortia, which involve universities and companies in Europe and overseas. That's how I was involved in them. So I was involved, the 8 years that I was there, I was mainly involved in 4 projects. But in 2 of them, I was from the beginning till the end, and they were my favorite ones, let's say.
How did these experiences maybe shape or help you get to where you are today?
So first of all, I realized that water is not a resource which is for granted. This was something that I believe most of us, me included, haven't realized. And there are areas which are not far away or in the middle of nowhere. There are areas which we visit and we live in, which face severe water scarcity problems. I was feeling very strongly that we have to find a solution. I somehow started loving wastewater as an alternative resource to solve this problem. Also, I started loving the idea of, because also from my engineering background, I think that technology will give the solution to this problem.
And going off of your passion for like finding solutions for water, I also heard that you are working with MIT with similar issues. What brought you to MIT?
After doing my PhD, which was in wastewater reuse, so how we can treat wastewater actually in order to have a specific quality and be again reusable and useful for agriculture, industry, domestic uses, or even for potable purposes. So then I was involved in a project which had to do with wastewater treatment and water treatment technologies. I was very curious developing a technology myself. So I wanted my postdoc to be in that specific topic. Then I've heard of the Center for Bits and Atoms, which is the place that I'm doing my research at MIT, which is an incredibly interdisciplinary place. And all the sciences are under the same roof here. This place focuses on exploring the interface of the nature and the biology and the digital world and computer science. So that was something very interesting for me. And I was a big follower of our director, Professor Neil Gerstenfeld. I also met an incredibly inspiring guy and a big researcher here, Dr. Andreas Mersin. And I was sure that I wanted to come here to develop this technology, which has to do with water treatment, as you can imagine.
So you were describing a little bit of like your research. Is there any possibility for real life application of it? Like, can you describe a little bit of what you did specifically?
My research focuses on an emerging issue, which is micropollutants. I don't know if you heard of this. So micropollutants are pollutants which are found in very, very small concentrations, trace concentrations in the water bodies, and are coming from substances that all the recent societies today use, such as chemicals, drugs, hormones, antibiotics, heavy metals. These substances are released through the wastewater system in our water bodies. And even though the wastewater and the water undergoes specific treatment, current technologies are not made for removing specifically these pollutants. So these pollutants remains in the system. And because water is a cycle, we also consume them. It's the same thing with the microplastics. Are in the ecosystems, in the fauna, everywhere. This is a huge problem because these compounds are associated with specific diseases. They are toxic. So my technology focus on this. And the goal is to remove heavy metals and drugs in tiny concentrations out of water. And for doing that, I want to use microorganisms. In other words, bacteria or algae or fungi. Also use the 3D bioprinting technology and combine all these things together in order to make a new technology which will be sustainable and affordable and will not consume a lot of energy for treating water.
Do you have any advice for people who are pursuing these goals? You seem really passionate about it. And I'm assuming a lot of other people might also want to do something very similar in their careers related to water.
So this advice is from my experience, and it's something that I learned very recently and I'm trying also to implement. And it's not to punish yourself. I mean, because research and experiments and writing your thesis and reading papers are stuff which are mostly you yourself and you. And you have a lot of times where you don't feel that motivated or when you just cannot concentrate in front of a screen anymore. And personally, I used to like punish myself during these times. And I realized afterwards that this thing decreased my productivity. Yeah, if you just take a break and do something else and not feeling guilty, the other day will be better. And inspiration and productivity will come to you.
So I just wanted to mention that you're now the co-president for MIT Water. Congratulations on that. Would you be able to explain what MIT Water is a little bit?
It's the premier network for water research and innovation at MIT. The mission of MIT Water is to bring together individuals, researchers, researchers, common people, whoever is passionate, creative, and motivated about water and wants to be part of developing solutions to the present challenges.
If you were to look at the future, what would you like to see when it comes to water and sustainability?
Well, I would like to see bigger penetration of alternative water resources. And by alternative water resources, I mean desalinated water and treated wastewater, because I believe that, especially concerning treated wastewater, wastewater is a research which is produced every day with a very constant supply, and there is no point in wasting it, especially in areas which are struggling with water scarcity. And then I would love to see new technologies for removing harmful compounds out of water, such as micropollutants or microplastics. I would love to see available water of good quality everywhere.
Right, so I think that's all it will be for questions. This might be a good place to wrap up. And yeah, just it's nice to see you, Patricia, and I'll see you next time.